Welcome students. Today's video is on solving systems of equations by substitution. First, let's start with some basic substitutions. Substitution is just like in sports when you need to sub someone in off the bench. They take the same position, or if you have a substitute teacher. So if I tell you to substitute 3x in for y, all I'm asking you to do is take 3x and have it take the place of y. So, where I see y right here in the equation, 3x will take its place. So that will become 3, and then 3x, in for y, plus 4. Now, if I simplify this out, 3 times 3x is 9x plus 4, and that would be your entire answer. So that's a basic substitution. This next one is a little bit more complex. Now they want us to take negative 4x plus 3 and put that in for y. So I'll find the spot where my y is, and now I'll repeat everything that was already there, so negative parenthesis, and instead of writing y, I'll write negative 4x plus 3, and then whatever was left at the end, so plus 2, we'll close it with a parenthesis. Now, I need to simplify by applying that negative on the outside. That means everything flips signs. So this will become 4x minus 3 minus 2. I'll combine my like terms, so negative 3 and negative 2, and I can get 4x minus 5. And that would be my entire substitution. With a system of equations, we're going to use this method to find our x and our y. Step 1 is we're going to make sure that our equation is solved for either x or y. So in other words, you want to see an x equals or a y equals. If you see that, you're ready to go. Step 2, we're going to take whatever that's equal to, and we're going to sub it in for x. Or, if it's equal to y, we'll sub it in for y. Then we're going to check our solution. So let's go through an example of this, and hopefully it'll make a little bit more sense. So again, step 1, check to see if one of your equations is solved for x or y. I see that y is equal to 3x. That means 3x can replace y. So, in my original equation, x plus y equals 12. If 3x can take the place of y, I'll just put it in right where my y is. That means I get x plus 3x equals 12. Again, I'll try to combine any like terms I can. X and 3x can combine to give me 4x equals 12. And now I can divide by 4 and figure out x is equal to 3. Now remember, from graphing, we learned that our solution is an ordered pair. So it's not enough to just have the x. Now that I know x is 3, I can easily figure out what y is. So looking back at this original equation, y was equal to 3 times x. So y is equal to 3 times 3, which means y is 9. So as of right now, I have an ordered pair solution of 3, 9. Now, to guarantee I have this right, I want to double check it with my equation. That means I'm going to plug it back in. So my first equation, x plus y equals 12, I'm going to say 3 plus 9 equals 12, which is true. And then I'll just double check with the second equation. Y is 9, which is equal to 3 times my x, which is 3. So y equals 3 times 3, that is right. And so I have guaranteed I have the right answer. And that is the ordered pair 3, 9. Try this one on your own. Unpause the video when you're ready to check. Again, we determined y was 4x. That meant with our original equation, x minus y equals 9. I could put 4x in for y. So I would do x minus, and I'd sub in that 4x equals 9. Then I'd combine my like terms. So x minus 4x is negative 3x equals 9. I divide by negative 3, and I figure out x is equal to negative 3. Now that I know that, I'm going to plug it back into one of the originals. So y is equal to 4 times negative 3, which is negative 12. Now I have the solution that I think is correct, and that's negative 3, negative 12. I just need to double check it to make sure it's right. So I'll plug it into the first equation. X minus y equals 9, so negative 3 minus negative 12 equals 9. Remember, subtracting a negative is the same as adding the opposite. So I have negative 3 plus 12, which turns out to be 9, which is equal to 9, and that's true. Now I just need to check it with my bottom equation. Negative 12 is y equal to 4 times x, which is negative 3. Negative 12 equals negative 12, so I've checked it, and I have the right answer. This example is going to be a little bit more complex because we've added on that minus 7. However, the process will still be the same. So I'm going to rewrite my top equation, 2x plus 3y equals 3. This is what we're going to sub into. Everything will stay the same. I now just know that my y right here will be replaced with 2x minus 7. So 2x plus 3 times my y, which is now 2x minus 7, is equal to 3. Now I just need to solve for x, which means I distribute first. That will give me 2x plus 6x minus 21 equals 3. I can combine like terms, so 2x and 6x can become 8x minus 21 equals 3. I can add 21 to both sides. That gives me 8x equals 24. If I divide by 8, I figure out x is equal to 3. Now that I know that x is 3, I can plug it back into this bottom equation. So then y is equal to 2 times 3 minus 7, which is 6 minus 7, so y is equal to negative 1. This gives me an ordered pair solution of 3, negative 1. Now, I want to plug these back in and double check to make sure that's the right answer. So, 2 times x, which is 3, plus 3 times negative 1 equals 3. So 6 minus 3 equals 3 is true, so I've checked it for the top equation. And for the bottom equation, y, which is negative 1, is equal to 2 times 3 minus 7. So negative 1 equals 6 minus 7, or negative 1. I've checked it, and that's correct. That tells me 3, negative 1 is the correct solution. Try this next example on your own. Unpause the video when you're ready to check. If you plugged 4y minus 2 in correctly and distributed, you solved and got y equals 2. Then you would have plugged that back into the bottom equation and figured out x was equal to 6, which gives you the ordered pair 6, 2. Then you checked your answers, both of them came out true, and you knew you had the right answer. This is our first example where one isn't solved for x or y already. We can either choose to work with the top equation or the bottom equation, and it won't make a difference. I'm just going to use the top, and I'm going to get x by itself. So x minus 2y equals 5. I see that all I have to do is move that negative 2y, so I'm going to add it to both sides. And that gives me x is equal to 2y plus 5. Now I know 2y plus 5 can take the place of x in the bottom equation. So I'll rewrite it. 3 times 2y plus 5 plus y equals 8. Now I just need to solve. 3 times 2y is 6y. 3 times 5 is 15. Plus y equals 8. So 6y and y can add to give me 7y plus 15 equals 8. I can subtract 15 from both sides. That gives me 7y equals negative 7. Divide by 7 and get y is equal to negative 1. Now I can plug this back in to either of my original equations. So 3x minus 1 equals 8. If I add 1 to both sides, I get 3x equals 9. Divide by 3, and I figure out x is equal to 3. Now my solution is the ordered pair 3, negative 1. This is another one where, once again, I have to solve for either x or y. If I see x sitting right there, I know that all I have to do is subtract that 4y from both sides. So now I know x is equal to 6 minus 4y. That means I can take 6 minus 4y, and I can put it in for x in the top equation. So 3 times 6 minus 4y minus y equals 5. I'll distribute. 3 times 6 is 18, minus 12y minus y equals 5. I'll combine my like terms and get 18 minus 13y equals 5. If I subtract 18 from both sides, I get negative 13y equals negative 13. And then next I want to divide by negative 13. This gets y alone, and it's equal to 1. Now I can plug it back into either original. So I'll say x plus 4 times 1 equals 6. So x plus 4 equals 6. That means x has to be 2. And now I have the ordered pair equation 2, 1. Let's try this next one, subbing them in. So 2x minus 3 is going to go in for y. So with my original equation, I have 4x minus 2. In this place, I'll sub in 2x minus 3, and that's equal to 6. I'll distribute, which gives me 4x minus 4x minus 6, or plus 6, equals 6. Now notice when I combine like terms, my x's are going to go away, and I'm left with 6 equals 6. This is a true statement, and if you ever get to something like this, that means you have infinitely many. Now, if the statement was not true, that would mean that there's no solution. But because 6 equals 6 is a true statement, there's infinitely many. Let's try this next one. We see x is already solved for, so I can plug this right in. That gives me 5 times negative 3y plus 1 plus 15y equals 10. Now, one way to check yourself and make sure that you're doing these right, if when you've written your equation you have all one variable, so all x's or all y's like you see here, you know that you wrote your equation correctly. Now I'm going to distribute. That'll give me negative 15y plus 5 plus 15y equals 10. Again, if I combine my like terms, negative 15 and positive 15y cancel, and I'm left with the statement 5 is equal to 10. I know that's not true, and that means there is no solution to this system of equations. Try this last one on your own. Unpause when you're ready to check. If you plugged it in and solved it correctly, you got 8 equals 8, which is a true statement, so you have infinitely many solutions. Thanks for watching.